So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the GCSE higher maths topic of indices, calculating with different bases. Now sometimes when you're multiplying or dividing numbers written in index form, in other words powers, we cannot apply the rules of indices as their bases are not the same. So for example here, if we're asked to calculate 32 times 2 to the power of 15, so if I just take this question out with a bit more space, so here 32 times 2 to the power of 15, well, even though the power is 1, I can't just and we're multiplying, I can't just simply add the powers together, so that becomes 16, and then multiply the base numbers, so that becomes 64 to the power of 16, because that there is wrong. And likewise with regards to question 2, if I try to work that out, that is going to be a huge number, in which again it's not going to be 1, it's going to be very time consuming to work out, but 2, it's going to be near impossible for me to write that answer in index form just off the cuff of my head. Also with regards to question 3, here we've got roots and we've got powers, and we've got a negative indice as well. So here I've got 4 to the power of 16 to the power of 5 divided by 2 to the power minus 3. Now you might be thinking to yourself, right, do you know what, I know the rules of indices, so I know that this number here is going to be 16, and then here I've got to the power of 5 to the root of 4 over 2 to the power of minus 3, but again the base numbers aren't the same, so I can't just simply take away those powers. And again with regards to question 4, same thing applies. The problem I've got here is I can simplify this, which would give me 2 to the power of 15, but then I've got this 8 in which there's nothing I can do with that because these base numbers are different. Now though there are no rules for adding and subtracting numbers written in index form, when multiplying and or dividing we should look closely at the numbers being used to see if they can be converted into index form with the base number already in the calculation. So for example, here's our question. We want to calculate and writing our answer in index form. So looking at some of the examples that we just briefly saw, but actually working them out. So here I've got 32 times 2 to the power of 15. Now what I can do is I can write 32, and if I put that in brackets, I can write that as 2 to the power of, and then just work out how many 2's you need. So that's going to be 2, 4, 8, 16, 32 is going to be to the power of 5. And that becomes there. So all I've done is I've just changed this number. Now the brackets mean absolutely nothing, it's just to identify that I've changed that 32 for 2 to the power of 5. And now because the base numbers are the same, I can then apply the rules of indices and simply, as I'm multiplying, add the powers, so that gives me 2 to the power of 20 as my final answer. Looking at question 2, here I've got a mixture. So here I've got 32, so I can rewrite 32 as I've said before, as I did in the previous, as 2 to the power of 5. 27 I can write as 3 to the power of 3. Then I've got 2 to the power of 9, and 81 I can write that as 3 to the power of 4. So all I've done is just replace some of the numbers. Then if I group the 2's together, get 2 to the power of 5, 2 to the power of 9 multiplied by 3 to the power of 3, 3 to the power of 4. Now I can do that because the order in which you multiply numbers does not have an impact on the answer, whereas with dividing and subtraction it does matter in which the order in which you do things. So here, collecting these two things here, I get 2 to the power of 14 multiplied by 3 to the power of 7, and that there would be my final answer, leaving my answer in index form. Now obviously there's close links to prime number decomposition in which it applies the same sort of thing. Moving on to question 3, so here we've got a power and root. So if I go back to what I originally wrote in the example, so here I've got, this is going to be 16 to the power of 5 over 4 over 2 to the power of minus 3. Then with this 16 I can rewrite that as 2 to the power of 4, and that's going to be to the power of 5 over 4 to the power of 2 minus 3. Then from this I can multiply out the powers because I've got brackets, so that's going to be 4 times 4/5. Now if you're struggling in terms of multiplying whole numbers by fractions, just convert that whole number into a fraction. So then multiply the numerators, which gives me 20, and it'll be 20 over 4, which is 2 to the power of 5, and that's going to be over 2 to the power of minus 3. Now when I'm dividing, I take away the powers, so that's going to be 2, 5 minus 3, which gives me 2 to the power 8 as my final answer. Moving on to question 4. So again, all I need to do here is just convert that 8. So that'll be 2 to the power of 3, multiplied by 2 to the power 5, multiplied by 2 to the power 10. Then adding the powers, now that all my base numbers are the same, I've got 3 plus 5, which is 8, plus 10, which is 18. Then finally, moving on to question 5. Again, I might just have to rub some of these out, just so I've got a bit more space. I think that should be enough. So then moving on to this, if I convert 64 as 2 to the power of 6 times 2 to the power of 6. Now here I've got square root of 128, so I can write 128 as a power of 2, and that's going to be 2 to the power of 7, and then that's square rooted, times, and I can write 16 as 2 to the power of 4 to the power of 3. Now if I just do a bit of simplifying, I've got 2 to the power 12 at the top, then here I've got 2 to the power of 7 over 2 multiplied by 2 to the power of 12. So here I've got 2 to the power 12 over 2 to the power of 7 over 2 times 2 to the power 12. Now only with this, what I could do is simply add the powers. So here that would give me 3.5, so it'd be 2 to the power of 15.5 if I was to write it as a decimal, and 2 to the power of 12, and that then becomes 2 to the power of minus, and it's going to be 3.5. Now alternative to that, what you could have done is simply cancel the 12s out, wrote it over 1, and then we've got the reciprocal of 2 to the power of 7 over 2, which is 2 to the power of minus 7 over 2, and any of those would be perfect as your final answer. Now for non-calculator questions, think of indices or prime number decomposition. So if you get this on a non-calculator paper and you don't recognise the numbers, then all you need to do is just do a little simple factor tree to try and work it out. So for example, if I had 32 times 2 to the power of 5 over 2, well, if I took 32 and then just did some prime number decomposition, 4 and 4, 2, 2, 2, 2, I can see straight away that 32 is 2 to the power of 5. So that's one way of doing it. Now if you've got it on a calculator paper, this is going to be even easier. So if I just drag a calculator in, so let's say I wanted to do 16 times 2 to the power of, let's say 7, multiplied by, let's go for 32, and press equals. Now that's going to give me a large number there, but then if I then press shift and this little fact key, it will then give me the answer as a power of 2. And the same thing applies if I've got a mixture of different numbers. So 27 times 64 times, let's go for the square root of 32. Let's go for divided, let's scroll out, divided by, let's say 3 to the power of minus 2, press equals. Again, it gives me a number, but if I press shift, in fact, does this still work? No, it doesn't. It gives me a maths error. So let me just go back and do this manually. So it's probably a poor example I've picked there. So let me just edit that and just go for 2 to the power of, let's say 10, and multiplied by 3 to the power of minus, I think it's the minuses that's triggering this off. Let's go for 7. Press equals, gives me a large number, but if I press shift and this fat key, it will then automatically give me the answer in index notation as powers of 2 and 3. So that's one way you could do it on a calculator. Now basically one thing that you want to look out for are these numbers. So if you do have quite a nasty calculation and it resembles a indice question or it resembles a product of their primes, then what you want to do is look out for these key numbers, and what you want to do is be able to know how to convert one from the other. So recognize that 16 is 2 to the power 4, 64 is 2 to the power 6, 25 is 5 squared, 1000 is 10 to the power 3, 27 is 3 cubed. And again, you shouldn't have to remember these as like a spelling test. It should be a case of just being able to know and recognize these numbers and be a little bit suspicious when these numbers are mixed in with powers of different bases. You also want to be aware of fractions, and also don't forget the rules of indices. So when you are multiplying, you add the powers. When you are dividing, you subtract the powers. When you've got a bracket, you multiply the powers. When you've got a fraction, the numerator is the power and the denominator is the root. So just be mindful of those things. But like I said, it's not always a case of going from this to this. It may be a case of going in the opposite direction as well. So now let's have a look at some past exam questions looking over this particular topic. Now, if you're wanting a copy of these questions and wanting to have an attempt at these questions following on from what we've just discussed, then all you need to do is just click on the link in the description and it will send you to this document and have a go at it, and then just simply come back to this video as we go through the answers. So looking at question 1 for 2 marks, it says C equals 2 to the power 10 times 3 times 5 to the power 6. Work out 18C, give your answer as a product of their prime factors in index form. Now again, if you've not had a chance to print it and you want to have a go at this question, simply pause the video, have a go at it, and then unpause, see what we go through the answer. So looking at this particular question, here we've been given C. So what I want to do is I want to multiply all of that by 18 to get 18C. So 18C is going to equal 18 lots of 2 to the power of 10 times 3 times 5 to the power of 6. Now with 18, what I want to do is I want to recognise that I can write that as a product of their primes. So that's going to be 2 times 9 and then 3, 3. So 18 equals 2 times 3 squared. So what I'm going to do is in this particular question here, I'm going to swap 18 for 2 times 3 squared. So what that then becomes is 2 times 3 squared times 2 to the power of 10 multiplied by 3 times 5 to the power of 6. Now with these numbers that don't have powers, I'm just going to simply write a 1 there just to make the use of the rules of indices that little bit easier. So from this, looking at the 2's, I'm going to be like collecting like terms. So when I'm multiplying, now if you want to rewrite it, that's absolutely fine, but again, not really essential. So here, 2 to the power of 1 times 2 to the power of 10 is going to be 2 to the power of 11. Then if I look at the powers of 3, I've got 3 squared times 3 to the power of 1, which is 3 to the power of 3. And then looking at the last one, I've got 5 to the power of 6, which stays the same, and there is my final answer. Moving on to question 2, it says simplify 8 to the power of 4 divided by 32 to the power of 2 over 5. So again, what I want to do is I recognise that 8 and 32 can both be written as a power of 2, and again a clue is in the question. So here, rather than writing 8, I recognise that 8 is 2 cubed and 32 is 2 to the power of 5. So swapping those, what I then end up with is 2 to the power of 3 to the power of 4 divided by 2 to the power of 5 to the power of 2 over 5. Now here what I want to do is, because I've got brackets, I want to multiply out the powers, so that becomes 2 to the power of 12 divided by, now 5 times 2/5, again if I change that into a fraction, 5 times 2 is 10, over 5 is 2 to the power of 2. And then here when I'm dividing, I take away the powers, which leaves me with an answer of 2 to the power of 10. Moving on to question 3, it says write 27 times 3 squared to the power of 7 as a single power of 3. So again, clue is here, I just need to convert 27 and write that as a power of 3. So 27, and again if you're not sure, simply do a factor tree and you recognise that 3 cubed is 27. So what I've got is I've got 3 cubed multiplied, when I've got brackets I multiply out the powers and then add the powers to give me 3 to the power of 17. Moving on to question 4, it says work out the value of 8 to the power of minus 2. So again with a negative power, that's going to be 1 over 8 squared, which is 1 over 64, which is our fourth option. Now again, don't automatically think you have to do this with every single number. Again, what I could have done is written this as 2 to the power of 3 to the power of minus 2, and that then would have given me Actually, not to the minus 2, that would have been positive 2. And that would have given me 1 over 2 to the power of 6. That's not even an option, so I'd then have to work out what 2 to the power of 6 is, which is 64, and it would still give me the same answer. Looking at question B, it says solve this. So again, what you want to do here is change the bases of 4 and 8. So 4 is 2 squared and 8 is 2 cubed. So changing this, I get 2 squared to the power of x equals 2 cubed to the power of 2 over 3. Then multiplying the brackets, I get 2 to the power of 2x equals 2 to the power of, well, 3 times 2 is 6. 1 times 3 is 3, so 6 over 3, which is 2. So here then, from this equation, 2x must equal 2. So 2x equals 2, so therefore x equals 1. Moving on to C, it says simplify, and we've got this, and again, just make sure that if your printout has not come out great, that there is a plus. So here, simplifying the brackets first, so 3 to the power of 0 is just 1, times 3 to the power of 1 is just 3, plus 9, all square rooted. So that then becomes root 12. And then from root 12, I can write that as root 4 times root 3, which gives me a final answer of 2 root 3. So again, mixed in with a lot of thirds there. Moving on to question 5, it says that a microscope slide has 2 to the power of 8 bacteria on it. The number of bacteria doubles each hour. After how many hours are there 8 to the power of 4 bacteria on the slide? Now, for this, there's not much I can do with this, but there is something I can do with this, because what I want to see is basically do 8 to the power of 4 divided by 8 to the power of 8. So looking at this, now from this what I then want to do is look at 8 to the power of 4, and I can write 8 as 2 to the power of 3, so that then becomes 2 to the power of 3 equals, to the power of 4 equals 8 to the power of 4. And then multiply the powers, so that becomes 2 to the power of 12 equals 8 to the power of 4. So I want to know from 2 to the power of 8, the amount of bacteria doubles to give me 2 to the power of 12. So again, thinking about doubling, it's just increasing the actual power. So here, all you're doing here is doubling the power. So basically multiplying it by 2. So how many 2's are the difference between this and this? Well, what's the difference in the powers? Well, that's going to be 4, so it's going to be 4 hours. Moving on to question 6, it says 2 to the power of m equals 32 and 9 to the power of p equals 3m. Work out the value of m and p. So let's have a look at this. So here, looking at this, we've got 2 to the power of m equals 32. Now 32 I can write as 2 to the power of 5. So 2m equals 2 to the power of 5, which means that m must equal 5. Then using this, I've got 9 to the power of p equals 3 to the power of m. Now I can write 9 as 3 squared, and I can write m is now 5. So here I've got 2p equals 3 to the power of 5. So that means that 2p must equal 5, and so therefore p equals 5 over 2 or 2.5, whichever you prefer. So here m equals 5 and p equals 5 over 2 or 2.5. I wouldn't recommend writing both of those, but either as a fraction or a decimal should be good enough to get you the 4 marks there. Moving on to question 7, it says given that 3 to the power x equals 9 x plus 1, work out the value of x. So again here what we want to do is want to rewrite 9 as a power of 3. So 3 to the power of x equals, and that's going to be 3 squared x plus 1. Then what do we do to the powers when we've got brackets? We multiply them, so that's going to be 3 to the power of x equals 3 2x plus 2. So that therefore means that those powers must be the same. So here we've got x equals 2x plus 2. If we take the 2 over to the other side and the x over to the other side, we end up with minus 2 equals x. So x equals minus 2. Now looking at question 2, it says find two sets of values for c and d such that 16 to the power of c equals 2 to the power of d. Now with this, it's a little bit more complicated rather than changing the bases, because in this case it wouldn't actually be of any benefit. So what you want to do is think to yourself, okay, well 2 to the power of what gives me something to the power of 16. Now with powers of 16, I've got 16 to the power of 1, which is 16. 16 squared, which is going a little bit crazy because that's going to be 16 times 16, which is 256, which is absolutely fine. 16 to the power of 3, again, is going to be where it starts going a little bit crazy, so we've got 4096. Whereas 2 to the power of 1 is 2, 2 squared is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, 2 to the power of 7 is 128, and 2 to the power of 8 is 256. Now what we're looking for are numbers that appear in both situations. So here we can see that 16 appears in both. So for this to balance, I can have 16 to the power of 1 equals 2 to the power of 4. So one possible value for C and D is going to be 1 and 4. Then another combination that also works is 256, which I see in both lists. So I can have it as 16 to the power of 2 equals 2 to the power of 8. So C can equal 2, and we can also have 8 as well. Now there are other combinations you could have. I could have C and D both equaling 0. So 16 to the power of 0 is 1. 2 to the power of 0 is 1, and that would balance. You can also go into, let's say, fractions as well, but I would say out of all the common answers, I would either go for one of those, two of those three possible answers. For question 9, it says that show clearly that 4 to the power of, and again that's going to be really difficult to see on the screen, but that is a 3 over 2. So we just rewrite the question. So it's 4 to the power of 3 over 2 equals 8. So for this, what we've got is that this here is, well, we can write that as 2 to the power of 2 squared, and we've got 3 over 2. And we've got, so multiplying out the powers, we've got 6 over 2, which is 2 to the power of 3, and 2 times 2 times 2 equals 8. And there you go. Or what you could do is just say that 8 is 2 cubed and show that they're both 2 cubed, and that will be fine as well. So there's quite a few different ways of showing that those two things are equal, but one of them would be absolutely fine. That says hence or otherwise, work out the value of y when we've got 4 to the power of y equals 8 to the power of 6. Now for this, again, what you want to do is write these as powers of 2, because obviously 4 and 8 can be written as powers of 2. So 4 is 2 squared and 8 is 2 cubed. So rewriting this, we get 2 to the power of 2y equals 2 to the power of 3 to the power of 6. Now expanding those brackets out, we get 2 to the power of 2y equals 2 to the power of 18. So 2y and 18 must be equal. So therefore y must equal 9. Then moving on to our last example, it says question 10a, work out the value of 9 to the power of minus 3 over 2. So 9 to the power of minus 3 over 2. So for this, again, the minus makes it the reciprocal. I've got 9 to the power of 3 square rooted. Now, looking at squares and cubes, you just think to yourself, what's easier to do? Well, it's easier for me to square root 9 because it is a square number. So that becomes 1 over 3 cubed, which then becomes 1 over 27. Now, I'm going to leave it as a fraction because, again, writing it as a decimal is going to be too complicated. Moving on to the last part then. So it says work out all solutions of the question of 8 to the power of m equals 2 to the power of 2m squared. So I've said that wrong. So 8 to the power of m equals 2 to to the power of m squared. Now again, with this, what you want to do is rewrite the power of 8 as a power of 2. So that's going to be 8 equals 2 to the power 3. So that's going to be 2 to the power 3m equals 2m squared. So from this, what we've then got is 2 to the power of 3m equals 2m squared. So therefore 3m equals m squared. Now the question says to work out all the solutions. Now at this stage you might be very tempted to simply divide both sides by m, so you're left with m equals 3. Now that's just one answer. Now here, the fact that it says all solutions must mean that there are other solutions. Now when you come to this kind of situation, you do not want to be dividing by letters, because technically m could equal 0 and you can't divide both numbers by 0. So at this particular stage, what you then want to do is take the 3m over to the other side and turn it into a quadratic. So 3m minus 3m, sorry, m squared minus 3m equals 0. Now at this stage, what you then want to do is factorize, and then you can find that there are going to be more solutions. So here m could equal 0, or m minus 3 equals 0, so therefore m equals 3, and there are my two solutions. So here m equals 0 or positive 3, and there we go.